Hello dear students, in this video I will teach you how to find the slope of a line. And I want to start by making you analyze these 6 lines. So we have line A, line B, line C, line D, line E, and line F. So we will group this into 3. I will pair line A, here is line A, with line F. Okay, A to F. And I want you to find the right pair for line B. So line A is to line F and line B is paired with what line? In the same manner that I paired line A with line F. And I will ask the same question with line C. So B is paired with what? And also C. Paired with what line in the same manner that A is paired with F? I know this is very easy. So A to F, B to, okay, line B. B is paired with line D. And of course, the last one, line C is paired with line E. I hope we have the same answer because that is a very, very simple activity. Now, considering that we have the same answer, let us see how we came up with those answers, or let us complete the statement here. Lines A and F have the same or have equal, have common, blank. That is also the same word that we're trying to find for the, for B and D, C and E. Look at A and F. What is common between these two? The same thing with B and D, and also C and E. Now, I just want to share, let me share with you the answers of my students whenever I ask these questions. Many would say position. So they say A and F have the same position, that is acceptable. Others would say direction, that's also logical. And others would say angle. Although we don't see any angle here, I understand their answer. A and F have the same angle if these lines form the ray of an angle and the other ray is a horizontal line. But what exactly is that word that we're trying to find? It has 5 letters, and that word is slope. Okay, line A and line F have the same slope, the same thing with lines B and D, and lines C and E. They have the same slope. Now, if we have the same answer with that very simple activity, I'm telling you, you already understand what slope means, even without memorizing its definition. But let us give a simple definition of slope. So the slope is the measure of the steepness of a line. So I wrote here slope of a line. In mathematics, whenever we say slope, we are referring to the slope of a line. So it is the measure of the steepness of a line. But what does it exactly mean? What does steepness mean? So the root word is steep. To better understand steep, let us see. Let's go back to the 6 lines. Among the 6 lines, let us find the 2 or the pair which are considered the steepest, and let us find the 2 which are least steep. Now, when we say steep, we mean it is close to the vertical line. In Filipino or in Tagalog, steep means matarik, and it is different from mataas. Yes, whenever we say steep, it has nothing to do with the height, but when we say steep, it is close to the vertical line. Now, considering these 6 lines, let us find the 2 lines which are the steepest, or the 2 lines which are closest to the vertical line. Okay, let us find the pairs. Our choices now are only 3. So the steepest, of course, are line C and its pair and its partner, line E. So line C and line E are the steepest. And the 2 lines which are the least steep, of course, are line B, it is very close to the horizontal line. Line B and its partner, line D, they are the lines which are considered least steep. Now, in mathematics, we do not just say the steepest or the least steep. In mathematics, of course, we can measure exactly the slope or the steepness of a line. And in mathematics, the steeper the line is, the higher is its slope numerically. So let us start measuring or finding the exact steepness of a line. Let us consider this line. Let us call this line A. Okay, the question is line A steep? By the way, this small letter A is read as line A in geometry. That is how we name a line. We use a small letter. Whenever we use a capital letter, that is used to name point. Okay, so the question is line A steep? The answer is, it depends on where we are using it. But we can give, as I said, the exact measurement of its steepness. So how steep is line A? And how can we determine or measure the exact steepness of a line? Or how can we find the slope of a line? We will now use a very simple formula, which is slope is equal to rise over run. Now with this, we will use the symbol M, small letter M, for slope. Yes, it's a small letter M, not S. It's because it is derived from a French word monter, which means to climb. So M is the symbol for slope. So this formula also means the change in y over the change in x, or we can also express it this way. Slope is equal to the upward steps over the sideward steps. So rise, whenever we say rise, it is associated with upward motion. If I say please rise, of course you're going to stand up. It expresses an upward motion. And to run, you may say when you run, it is supposed to be a forward steps, but in order for us to measure it or to show it in writing, we can consider sideward steps. So it is upward steps or upward units, upward movements over the sideward steps, or rise over run. So to better understand it, let us go back again to line A. Step 1, to find its slope, is to put it in a grid like this intersection of lines. So now we will have our given line on a grid. Next step, okay, so this is the same line. I only make it bigger and change the color. So this line have the same slope with the line before. So this is still line A. Next, within the line, we need to consider points within the line which coincide with the intersection of the lines on the grid. So, in the line, actually, if we extend it, the point right here is already an intersection. It already coincides with the intersection of the grid, but this one is clearer. This point here is a point in the line, and it coincides with the intersection of this line, this vertical line, and this horizontal line. So in short, yung mga nag-i-exacto sa mga intersection. So another point is this point. It coincides with the intersection of the grid, and also this point and this point. And of course, if we extend this line, those points that we need are infinite. So let us highlight those points. Let us just consider 2 points. 2 points within the line which coincide with the intersection of the grid. Let us call this point point A and this point point B. Now, how do we use the formula rise over run? So let us write it. Slope, again, M's slope. Slope is equal to rise over run. Here is how we use it. From one point to the other point, let us count the number of steps that we need to reach the next point. And the steps should be perpendicular, or forming 90 degrees, or forming right angle, or we should only follow vertical line and horizontal line. There are no shortcuts with this. So from point A to point B, we need how many steps upward and how many steps sideward. That is what we mean by the formula rise over run. So let's continue. From point A, let us see. The number of steps upward that we need is 1, 2. So our rise, it is designated with the color orange. Our rise now is equal to 2. That's it. 2 steps or 2 units upward. Now from this step, let us see how many steps we need to reach our destination, which is point B. So that will be our run. And I use here the color green. So from this point, how many sideward steps do we need? And there they are. We need 1, 2, 3. We need 3 steps or 3 units. So that is our run. Our run is 3. So we now have our slope, which is 2 over 3. And yes, this is simply the fraction 2/3. So our slope is 2/3. Now, as I said, there are other points within the line which coincide with the intersection of the grid. So let us consider those points. Let us consider point C, point D, and even this point right here. Okay, let us call this point X. Now let us consider the two extreme points. From point X to point D, let us find the rise and the run. Of course, we are expecting the same answer here. The slope from point X to point D, because we are dealing with the same line. It is the same line. So the answer should be 2/3. So let us see. Let us use the same formula. Slope is equal to rise over run. The number of steps we need from point X, the upward steps are 8. 1, 2, 3, 4, 5, 6, 7, 8. So we'll stop here because this is our destination, point D. So the rise is now 8. Now from this point, let us count the number of steps or units we need to reach point D. And how many are those steps? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of steps sideward that we need are 12. So that's our run, 12. So look at our answer. The rise is 8, the run is 12. Did we get the same answer? So at first you might say we have different answers, but this 8 over 12 here is not yet reduced to lowest term. Okay. I told you before, our answers should be reduced to lowest term. So 8 and 12 have, it can still be reduced to lowest term. We can still find a GCF. They still have a common factor other than 1. We can divide both by 2, yes, but there is a number higher than 2, and that number is 4. So both 8 and 12 can be divided by 4. So 4 is our GCF. So let us divide 8 divided by 4. 2, and let us divide 12 divided by 4, 3. So our answer is the same. It's 2 over 3 or 2/3. This is also our final answer. Yes, we are supposed to get the same answer, whichever 2 points we're going to use. Let us say we want to use point A to point C, because as the rise increases, the run also increases proportionately. We will get the same answer. Next, so we were able to solve two slopes. The first one has a slope 2 over 3. Now, do we really understand how steep is this line? Of course, we can say we understand it because we see the line. But to understand it further, let us compare it with a line whose slope is 1. Let us consider number 1 and the number 2/3. which number is bigger, or which number has a higher value. Let me just use the word bigger for that, bigger or smaller. Which number is bigger, 2/3 or 1? Of course, the answer is 1. Because 2/3, in order for 2/3 to become 1, we still need 1/3. So 2/3 plus 1/3 is equal to 1. So 1 is bigger than 2/3. So it means a line with a slope 1 is steeper than a line with a slope 2/3. So let us now consider a line with a slope 1, and let us use it as our reference line or reference slope. So therefore, a line with a slope 1 is steeper than, I already discussed that. Let us now draw a line with a slope 1 and compare it with the other examples that we will have. But how exactly, or how steep exactly is a line with a slope 1? Before I give the illustration or the figure, can you try to think it by yourself? How steep is a line with a slope 1? 1, meaning the numerator and the denominator are equal. The steps upward is equal to the steps sideward. Okay, so let's continue. This line, let us call this line B. Of course, I said we will deal with the line with the slope 1. The slope of this line is 1, yes. But let us use the formula rise over run. So within this line, the points which coincide with the intersection of the grid there are many of them actually. And here they are. Let us have point A, point B, point C, point D, point E, and if we extend the line, there are again infinite points which coincide with the intersection of the grid. Now, to find the slope, just like what we did with point A a while ago, just like what we did with line A, we will consider only two lines. We will consider only 2 points. We can consider points A and B, can be A and C, B and C, B and D, B and E, any 2 points. And from one point to the other point, let us just count the rise over run. They are all computed here. So we can have a slope, if we consider point A to point B, for example, the rise that we need is just 1 step and the run is also 1. So we will have this computation, slope is equal to 1 over 1 and 1 divided by 1 is 1. What about if we consider point A to point C? Our rise is 2, but our run also became 2. So that is 2 over 2. The same solution will be needed for computation from B to D. The rise is 2, the run is 2. The same thing with C to E. The rise is 2, the run is 2. And 2 over 2 is equal to 1. And the same thing with a line, let us say, or with points from point A to point D. The rise is 3, the run is also 3. And 3 over 3 is equal to 1. Okay. The highest number I use here is 5. But considering the points that I highlighted, I can only have 4 over 4. If we extend it, or if we use this point here, we can have 5 over 5. But if we compute for the number of steps we need from point A to point E, again, point A to point E, the number of steps upward is what happened. Okay. From A to point E, we have 1, 2, 3, 4, and we'll stop here. The rise is 4. And the run, the sideward steps are 1, 2, 3, 4. So we have 4 over 4, and 4 divided by 4 is equal to 1. So the steepness of this line is always 1, whichever 2 points we use. Now, I want to emphasize here that for measuring a slope, the size of the grid or the small squares that we use doesn't matter. The first figure here have the slope or has the slope 1. The same thing with this one. It doesn't matter if the grid are small or big or if the line is what is thicker, or even if we show a lot of points, all these 4 lines have the same slope. The size of the grid doesn't matter. And try to observe the 4 lines. Don't they have the same steepness? So therefore, all these lines have the same slope. And their slope is 1. Slope is 1. Because from any 2 points or from 1 point to any point, the rise is equal to the run. Okay, so remember these lines. Their slope is 1. Now, using a line with the slope 1 as our reference, let us find the slope of lines which are less steep than 1 and these lines which are steeper than 1. Okay, I have here 7 lines, starting with a line whose slope is 1. So from these 2 points, from this point up to that point, the rise is 1, the run is also 1. So the slope is 1 over 1 and it's 1. Next, although the slope is already given, let us analyze it. From this point up to this point, the rise is 1 and the run is 2. Therefore, our slope is 1 over 2 or 1/2. And consider the line with the slope 1. Compare it with the line with the slope 1/2. The line with the slope 1/2 is less steep than the first line. And numerically, of course, 1/2 is smaller than 1. Yes, 1/2 means kalahati and 1 is 1/2. So, using those numbers to describe the slope of this line, the second line is less steep. And as if, look at the lines, from a slope 1, 1/2, 1/3, 1/5, 1/10, the lines seem to be getting closer to the horizontal line. Okay, a line with a slope 1/3, the rise is 1, the run is 3. A line with the slope 1/5, the rise is 1 and the run is 5. Okay, as if it really gets closer to the horizontal line, a line with the slope 1 over 10, consider this one, the rise is 1 and the run is 10. Now what about a line with the slope 1 over 20? The rise is 1 and the run is 20. Now, just try to imagine a line with the slope 1 over 100. With that, of course, I cannot draw it here. I can draw it, but I have to use smaller grid. So a line with a slope 1 over 100, try to imagine squares, 100 squares piled side by side, and draw a diagonal. You can hardly see the rise. A line with a slope 1 over 100 seems to look like a horizontal line, but it is not yet a horizontal line. Okay, now what about considering a line which is really horizontal? From a line with the slope 1, we are getting closer to the horizontal line. Now, this last example here is a horizontal line. So let us use the formula rise over run to measure its slope. So I highlighted here 1, 2, 3, 4, 5, 6, 7. I highlighted 7 points within a line. So from the first point to reach the last point, let us count the number of rise over the number of run or steps upward divided by the step sideward. So from this point to reach the last point, how many upward movement do we need? Upward steps. Of course, the answer is 0. From this point up to this point, you don't need to move any step upward. So the rise will be 0. Our numerator is 0. What about the denominator? What about run? Well, the answer is it can be any number. I can have 1 step up to this point. I am referring then to the same line. I can have 2 sideward steps. I can have 2, 3, 4, 5 or any other number. But here let me use 6. So run will be 0 and the rise is 0. and the run is 6. So we have 0 over 6. And try to recall, I emphasized this in our previous lesson, in the lesson rational algebraic expressions. When we reviewed rational numbers, we can use 0 as dividend, or 0 divided by any number has an answer, has a rational answer, and that answer is 0. Okay, so 0 divided by any number other than 0, the answer is 0. So the slope of a line which is horizontal is 0, because it doesn't have any steepness at all. That is why the slope is 0. Now consider these lines, starting with the line which has the slope 1. Again, the rise is 1, the run is 1, so it's 1 over 1. The next example, the rise is 2, the run is 1. Next, the rise is 3, the run is 1. Rise is 5, the run is 1. But before I continue, let me show these slopes. So here they are, starting with 1. Next, we have 2 over 1. The rise is 2, the run is 1. And 2 divided by 1 is 2. So we can say that the slope is 2. It is a whole number 2. And numerically, 2 is greater than 1, right? That is why, considering the lines with those slope, 2 is steeper than 1, and 3 is steeper than 2. And here, consider a line with the slope 5, the rise is 5, the run is 1. The lines are getting closer to the vertical line. Then we have 10 over 1, the rise is 10 against the run, which is only 1. So here is a line with the slope 10, or 10 over 1. Now, try to consider a line whose slope is 100, or 100 over 1. To imagine that, try to imagine squares which are piled upward. There are 100 of them, and try to get the diagonal of the rectangle being formed. It is really very close to the vertical line, but it is not yet a vertical line. It will give us 100 steps upward, then just 1 step sideward. Consider the diagonal now. That line has the slope 100. Now, what about if the line is really a vertical line? So let us consider this, and let us use the formula rise over run. Let us consider the bottommost point, because we need to rise from this point. So from this point, the rise can be any number. I said any number because from this point, if we will just make 1 step, those 2 points will be enough to describe the line. So we can use 1, we can use 2, we can use 3, 4, 5, 6, 7, 8, 9. So I use 9 because that is the distance from these 2 points. So I will use the rise 9. So rise over run, rise is 9. So I counted from here, I counted 9. Now this is already the destination. I no longer need to make any sideward step. So to reach the destination, the run or the steps sideward would be 0 because we are already here. So the run or the step sideward will be 0. And if we divide this, 9 divided by 0, or any number other than 0 divided by 0, is not equal to 0. Remember, division by 0 is not allowed, and the best word to use is the word undefined. So any number divided by 0, any number except 0, when we divide it by 0, it is described as undefined. So you see, if a slope, or if a line that is horizontal has the slope 0, a line that is vertical is undefined. Okay, so we have it undefined. So let's have a recap. When the line is horizontal, its slope is 0, or the slope of a horizontal line is 0. 0 divided by any number is 0. And the slope of a vertical line is undefined. Or when a line is vertical, the slope is undefined. Please do not interchange the two. The horizontal has no steepness at all. That is why it is 0. The vertical line seems to be very, very, very steep because it is already the vertical line. And numerically, we cannot give any number. That is why we use the word undefined for the slope of a vertical line. Now, what if the line is, or what if the line has a different direction? Now let's go back to the first example that I gave you. This one, let us review. Finding the slope, rise over run. From this point up to this point, the rise is 1, 2, the run is 1, 2, 3. Therefore, the slope is 2/3, 2/3. Now, what about this line? It seems to have the same rise and run, but it goes on a different direction. So let us see. From this point up to this point, the rise is also 2. The run is also 3, but it goes on the different direction. It is to the left. And as you can see, the line rises upward to the left. Will it have the same slope as the first one? So let us find the slope. So the slope now is negative 2/3 or negative 2/3. So the rise is 2. The run is negative 3 because it is on a different direction. Or we can also have, let us say from this point, the higher point, the higher in position. If we, from this point, we want to reach the other point, we can say that instead of rise, we will have a, how do we describe it, a fall. So from this point, we need steps downward, and then the sideward step will be positive, it is to the right. And the solution there will be negative 2/3, and that will give the same answer, negative 2/3. And because try to recall that positive divided by negative is negative, and negative divided by positive is also negative. Now, to make it easier, just remember, when a line rises upward to the left, it is negative. Just count the same and just have the same way of counting the rise and the run. So the slope of this line is 2/3, and this one is also 2/3, but it is negative. Okay, so let's have a recap. When the line rises upward to the right, the slope is positive. And when it rises upward to the left, the slope is negative. Now, let us have a complete recap of the four kinds of, four possible lines that we might encounter. So our choices here is positive, 0, undefined, or negative. So first we have a line which is horizontal, then a line which is vertical, a line which rises upward to the right, and a line which rises upward to the left. So when a line is horizontal, the slope is what? Horizontal, is it positive, 0, undefined, or negative? Okay, the answer is 0. When a line is horizontal, the slope is 0. When a line is vertical, or in a vertical line, the slope is undefined. When a line rises upward to the right, the slope is positive. Upward to the left, of course, it is negative. Okay, let us now try the following exercises. Let us see if you can find the slope of the following lines. You may consider pausing this video. Try to write your answers on a piece of paper and try to check them. Okay, pause the video and continue checking your answers. Okay, so these are the correct answers. Let us see. From this point up to this point, the rise is 3 and the run is 5. It rises upward to the right, therefore the slope is positive, and 3/5 cannot be reduced to lowest term anymore. In the next line, it rises upward to the left, so our slope is negative. The rise is 1 and the run is 4, so our slope is negative 1/4 or negative 1/4. In the third example, no need to count the rise and the run. It is a horizontal line, therefore the slope is 0. In the fourth example, from this point up to the next point, the rise is 2 and the run is 4. So we have 2 over 4. But 2 over 4 can still be reduced to lowest term. 2 and 4 can be divided by 2. 2 divided by 2 is 1 and 4 divided by 2 is 2. So the slope is 1/2. And on the last number, no need to count the rise and the run. It is a vertical line. So our answer is undefined. So I hope you got all 5 exercises correctly. If not, try reviewing the video. And I hope you learned something from this video. If so, please consider subscribing and share it with your friends if you think they need to understand the same lesson. So with that, again, thank you and have a nice day.